Hi guys. Today we did a lab on atomic mass. So I'm going to take you through how to start this lab and how to do the basic directions. But really, if you follow the directions and follow my example, this should be okay. So if you need to stop and watch a part of the video again, stop it. Okay. So basically, what you're going to need is if you go to Google Classroom and you go to today's date, Monday, okay, you're going to see three things that you need to have open. One is this Google Slides called Atomic Mass Lab. Two, Google Doc Atomic Mass Lab for the student version. And then this is where you have an option. You can either open the link to have the periodic table, or you can get out your periodic table of elements on paper. Okay. Then you're also going to need a calculator, and you can easily get a free calculator by just going to Google and typing in free calculator, or you can grab one maybe that you have for math. Okay, so I'm going to give you a second to do that. Again, you've got to have all three up. So you should have the Atomic Mass Lab with this lady saying, "Can you help me?" on the front. You should have something that looks like this and has a chart that needs to get filled out. And then you should have your periodic table of elements. Okay, so get all three of those right now. Okay, so we're going to start by going over the directions. So I'm going to go to the Google Doc. And if you want, you can just look at the screen. Okay, so basically, we've been talking all about atoms and all about the periodic table. And last week, you read an article about Mendeleev, the dude with the like white and silvery beard, who basically kind of created and started the first periodic table. And really, what he built most of it on was organizing it based on atomic mass. So he knew that every atom had a different weight. Some were lighter, some were heavier. And so he knew that, like, hey, if an atom is this weight, it probably is this element. And whether he actually knew the name of the element or not, he knew one existed because of its weight. So what we're going to kind of do is a little simulate that process by looking at 5 atoms that we don't know. We're going to find the weight of the 5 atoms, and then based on doing a little bit of math, kind of like Mendeleev did, we're going to try to figure out what those 5 elements are based on how much they weigh. Okay, so what we're going to use is some fake data. So unfortunately, we can't be in the lab together, but if we were at school, we'd be using these 2 things right here. And let me make it a little bit bigger. One is called a film canister. It's this black little container. You might have seen it before. Back when I was your age, we couldn't just take pictures and then upload them to computer or put them on a phone. We actually had to take the film canister, take film out of it, put it into a camera, take our pictures, take the film out, and then go have it developed somewhere. So that's a film canister, okay? We're going to be using that. And then we're going to be filling these canisters with washers. There's these like little metal circle things, and basically they're used like with nuts or bolts where you want to hold something down. So these washers are kind of light in your hand, but we're going to pile up maybe 1, 2, 20, 40 inside of this canister of different weights. And basically then what we're going to do is we're going to pretend this whole thing is an atom. Okay? The outside black part's going to be like the electrons that buzz around the outside. The washers inside are going to be the nucleus. So basically what I'm going to do is I'm going to give you, show you when that happens. Is I'm going to give you 5, oh my gosh. I cannot handle this today. Okay, come on. I'm going to give you 5 different washers. So we're going to do canister A, canister B, C, D, and E, and they're all going to be filled with different washers, but you're not going to know how many are in there. So we're going to do a little weight and a little math using a scale and a calculator to try to figure out what is actually inside to be able to determine the atom. So if that confuses you a little bit, let's go through the directions and I'll show you exactly how to do it. Okay, so the very first thing that we're going to do is we have to know how much electrons weigh and also the mass of just one washer. It would be like the mass of one proton, okay, in the center. So when we weigh it, if we weighed it in class, we'd find out that the empty canister was 0.25 grams and one circle was 1.25. So we're going to put that into our chart. So now you're going to go to your chart and you're going to do this with me. And on your chart under A, the mass of the empty canister, which if you remember, I wrote this means electrons, is going to be 0.25 grams. So we're going to type that in. And that's actually how much every canister is going to weigh. So go ahead and type 0.25 in for the whole row going across. 0.25 G, 0.25 G, 0.25, whoops, 0.25 G, 0.25 G, okay? I'll stop the video if you need to for a second to finish that. Okay, next, we're going to enter the amount of the nucleus. That's just like one washer, right? So a mass of one washer is 1.25. So now I'm going to enter that here, 1.25 grams, right? And that should make sense because if you remember, the nucleus is way heavier than the electrons. It's the heaviest part. So that makes sense that it weighs more than electrons. And actually, that's how much one proton or nucleus is going to weigh. So we're going to do 1.25 on all of these. Okay, stop the video if you need to. So now, basically what we're going to do is we're going to weigh the canisters with the different mystery amount of washers. So like canister A has a low amount, canister C will be higher, canister D will be a different amount. You're not going to know how many washers are in there, so we're going to weigh it, and then we're going to do some math to try to figure out how many washers there are in that atom and then match it up with the periodic table. Okay. So we're going to start by going to canister A's overall mass or weight. So I'm going to go to canister A, so the next slide, and see it says canister A. The canister with the washers is 1.5 total. So I'm going to put that down under A. We're just doing A now. So I found out that the total of atom or canister A is 1.5, okay? With a middle of 1.25 and an outside of 0.25. To give us 1.5 total. Okay, now here's the trickiest part, but you just have to really follow the directions, okay? What I'm going to do now is I'm going to do a little math. I'm going to take row 3 minus row 1. So here's row 3, 1.5, minus row 1, so 0.25. Okay, and when I do the math on that, it's basically like saying $1.50 minus 25 cents is 1.25. Okay, so now I've just gotten the answer, or what the question mark is. So now I have to do one more step in this box. I have to take the question mark answer, divide by row 2. So I'm going to take 1.25, what we just found the answer to be, and divide by row 2. Here's row 2. 1.25. So I'm going to do for this one 1.25 divided by 1.25. And if I did the math on that, I would get 1. This would have a mass of 1. Okay? So now, if you remember, atomic mass is that bottom number. So now all I have to do is go to my periodic table and find the atom that has an atomic mass of 1, a bottom number of 1. So, and that's the easiest, right? It's the lightest. So if I look at here, hydrogen has a bottom number of 1. So this mysterious atom actually ends up being hydrogen. And if you remember, hydrogen is the lightest, simplest of all the elements. And that's what Mendeleev did base everything on, right? He said like, hey, if an atom is 8 times hydrogen, then I know it's 8 times heavier, right? So that's kind of what we're going to do. So make sure this is all filled out, and let's try canister B. Stop the video if you need to. Okay, so let's try canister B. So the same thing remains, right? The electrons are 0.25. One washer is 1.25. But let's go and see what this canister B weighs. So we're going to go to slide canister B, and we're going to see what the end is. So it weighs, whoops, I got to move this over with the camera. It weighs 11.5 total. So we have an atom that totally weighs 11.5. So that's what I'm going to enter here, 11.5. So if you look at it, this one's much heavier than hydrogen, right? It's almost 11 times heavier than hydrogen, okay, or a little bit less than that. Okay, so now we've got to figure out what atom this is, so we're going to do the math. We're going to start by doing the next part, row 3 minus row 1. So here's row 3, 11.5, minus row 1, 0.25. Okay, and if we get that, we get eventually an answer of 11.25. We still have one more thing to go, right? We're going to take that answer and divide by row 2. So now we're going to do 11.25 divided by row 2. That's 1.25, 1.25. Okay? And our answer is going to be 9. Once I take 11.25 and I divide it by 1.2, I get 9. So now, just like I did with hydrogen, I have to find an atom on the periodic table that has a bottom number atomic mass of 9. So I'm going to look at my periodic table and I'm going to look for a bottom number of 9. And there it is. Bottom number is 9. That's beryllium. So I'm going to type that in, beryllium. Okay, and that's my mysterious atom B. Okay, let's do one more example together, then I want you to try it on your own and finish it and turn it in. Let's try C. Stop the video at any time. Let's look at canister C. Okay, canister C, we know, weighs a total of this atom. Whoa, weighs a whopping 100.25. Dang, this atom's bigger. Okay, so let's go type it in. This one weighs 100, whoops, I type 0.25 grams. Okay, now we've got to do the math. So we're going to go down here and we just follow the directions. We do row 3 minus row 1. So here's row 3, 100.25 minus row 1, 0.25. Okay, and when we do that math, we get 100 grams total. Okay, so we still have one more step. Now we've got to do 100 divided by row 2. So I'm going to do that math. I'm going to do 100 divided by row 2. Row 2 is always the same. It's always 1.25. So 100 divided by 1.25. When I put that into my calculator, I get an answer of 80. Whoa. So now I'm going to look at the periodic table and I'm looking for a bottom number of 80. So let's go ahead and look. And voila, there you go. Oh, here's 40, da, 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 da. Bottom number of 80 is right here. Is bromine, is 80. Okay, so bromine is my answer. Bromine, kind of a funny sounding. It's the bro atom. Okay, all right, so the next step for you is to find the weight of D and E, do the math, look for the bottom number, which should be like a solid, no decimal number, and then match it up with the rest of the periodic table, okay? So try to find D, try to find E on your own. If you need help, go through an example I just did again. It's the same steps, okay? And then when you're all done, submit it, and you're good to go. That's today's work, okay? All right, guys, have a great day.